Take a moment to do the explore and reason. Look at the painting, answer the questions: how many triangles are in the painting, and what strategy did you use to count the triangles, and how well did it work? Go ahead, pause your video and do that, and then come back to example 1. In example 1, we're going to identify corresponding parts of overlapping triangles ABC and DCB. So I'm just going to highlight these here so we can see what we're talking about. Triangle ABC. And we're talking about triangle DCB. So we have two overlapping triangles. We're going to identify the corresponding parts to that. We know that AB corresponds to DC. We know that AC corresponds to, I don't know what I wrote there. I should say DC. AC corresponds to DB. And then BC corresponds to CB. So if you're looking at those triangles separated, I'm going to write that in the other color so you see. We're talking about this being triangle A, B, and C, and then this being triangle D, C, B. So if we have sides corresponding, then we also have angles corresponding. So we have angle ABC corresponding to angle DCB. We have angle BAC corresponding to angle CDB. And we have angle ACB corresponding to angle DBC. Are these triangles congruent? Well, in this particular case, this was congruent to this. The reflexive property tells us that BC and CB were congruent. And then both of them were 90-degree angles in the corner. So these triangles are congruent by side angle side congruency theorem. Go ahead, pause the video and see if you can figure out the corresponding parts of H, J, and F to determine if those are congruent. On the try it, you were trying to determine if this triangle, HJF, was congruent to this triangle right here. So I wanted to go ahead and mark those so that we know what we're looking for. But we're going to go ahead and go back. I'm going to draw those off of here. Oops. So that we know that we're talking about this triangle and we're talking about this triangle. And that makes this H and K and G. And this triangle is H and F and J. So we will come back to those. In the meantime, I'm going to take those extra markings off there so we can see what's going on here in the picture. I want to look at the fact that this line right here has a 1 and a 2, and this line right here has a 1 and a 2. So we're going to kind of write an informal proof here just so we can follow ourselves. But we know that FJ is congruent to GK and that's because of the segment addition postulate. So the segment addition postulate tells us if we add those pieces together, then we're good to go. So let's mark that side congruent to that side in our picture. We also know from the given information that that angle and that angle are congruent. So going back to the picture, we have this angle right here congruent to this angle. So that is angle KLJ being congruent to angle FLG and because of vertical angles. So we know that these two little triangles are congruent by side angle side. So triangle GLF is congruent to triangle JLK, and that is by the side angle side congruency theorem. And then we can determine that angle FGL is congruent to angle KJL, and that is by CPCTC. So that is FGL, this angle right here, being congruent to this angle right here by CPCTC. And then we can draw the conclusion that this angle and this angle will be congruent because these are linear pairs. So we would say that KJL plus angle HJL equals 180, and also angle FGL plus angle HGL, that equals 180, and that's by linear pairs. And then from there, we can draw the conclusion that angle HGL is congruent to angle HJL by the transitive property. And so we can say triangle so that gives us this angle, and that gives us this angle right here. So we can determine that triangle HJF is congruent to triangle HGK by angle side angle.